We are in OneNote, noting that although you're not required to, if you have access to this OneNote file and would like to follow along with us, we're in file name, modal node system, MNS, in presentation 1110, Excel notes and numbering system, the only presentation we currently have, but we plan on adding plenty more to this file shortly. Also note that we're going to work most of these presentations as well in Excel, focusing more of our time on actually building the tables and therefore possibly a little less time on the theory stuff. More time on the theory stuff here then, hopefully. However, I highly recommend actually building these tables in Excel because like playing the guitar with your actual fingertips, you get that tactile feel that helps you to actually visualize the table, make them less abstract as well. So what we want to do this time is look at the normal numbering system that's going to be in our music theory, or the normal note naming system in our music theory. Think about why we would want to be putting in play a numbering system and how that might be helpful as we start to build on the ideas and concepts. In other words, build scales and build chords from this baseline, keeping in mind my major instrument that I'm going to be thinking about is the fretboard, although the same concepts do apply to all other instruments, including even the piano. I say even the piano because, like I say, us guitarists get jealous of the music theory oftentimes possibly being constructed with the piano at hand instead of the guitar in hand. But I even think that that could cause problems on the piano side of things, right? Because it still causes some issues that we have to kind of unlearn things when we learn things just because of the natural construction of the piano and the language. And those are the things that I want to keep on reiterating as we go kind of down the rabbit hole. I think that the general idea that I want to keep on reiterating is, if we built the system today, would we build a different system than the one that has been constructed as it has been built on top of each other over time? I think the answer to that is clearly yes, we would, if we were starting from scratch and didn't have the historical baggage, which then leads us to the question of, should I learn things in a faster, more efficient system because it'll be faster, but then I'll have to bridge the gap for communication purposes to the system that I'm currently in? My argument is always basically going to be yes, almost all the time. It's going to be better to learn faster and then bridge the gap back, particularly these days, given the resources that we have. So that's going to be the ideas that I'm going to keep in mind, noting that when I look at the fretboard, in particular, it's quite common these days for guitarists to learn in shapes. That's the natural way to learn the fretboard, which actually doesn't lend itself as easily to the numbering system, which is based on in scales. So I just want to keep leading into this idea as we learn these concepts and see why it is applicable. That means that most people learn the caged system. That's one thing that you're going to hear a lot about, meaning taking the open shapes in open position, moving them up in the fretboard. You might hear a lot about breaking the fretboard into 5 shapes that are putting together one master or giant shape, which is basically what we are looking at here. And those are the 5 positions that you could name with a caged system if you want. Bar chords is another way to just visualize the guitar in terms of shapes. So then when we convert that to language, though, we end up kind of having issues with the naming conventions of chords and with the interval naming convention, which wants us to rename every time we look at a particular point. So let me give you the general idea of this. If I learn this shape on the fretboard, which is one scale shape in the key of C, but which is completely copy and pastable, meaning maneuverable, that covers all 12 positions and all 7 times 12 positions with regards to the modes. So from a shape perspective, there's no argument really. I don't think anyone would argue that what you want to learn is this shape that you might then break down into 5 shapes or 3-note per string shapes or to a caged shape, but this shape that you can then move through the 12 positions. I don't think that's arguable. The question then is, how do I name each of the points within the shapes and the relative distances between them? The three methods we can do that is either we name the actual notes themselves, which works if you're playing in the key of C, just like playing all the white keys on the piano works if you only play in the key of C and related modes. 7 modes, not just the key of C major, 7 modes. But it doesn't work if you play in any other key and the 7 modes. So you've got 7 times 11 that it's not going to work in because I can't shift the shape up that way. That's the problem. Same problem you have on the piano. You can play all the white keys. It sounds cool. You don't need to even know what you're doing. You could just play rhythm. It's great. Super cool thing to do. But if you want to play in anything other than the key of C, you're not going to know how to add the other notes in if you don't understand why the key of C was put together the way the key of C. Then you have to, that's why the piano can kind of also mess people up to some degree, the way it's kind of laid out. It's really nice if you just play in the key of C, but then it becomes a little bit wonky to unlearn things when you're trying to see how to play other and apply the other shapes, which we'll see here. Now you can also think about relative scale degrees. That's more maneuverable. So what they did is they said, okay, well, let's number the system as a scale of 1 through 7. So the 1st through the 7th. Now, if I'm playing in the key of C, that's great because if I move up to a G or something, then I can shift the whole shape up and the shape now is copy and pastable. Problem, however, I can't move that system to play in another related mode, like the minor scale, for example, because then it wants me to renumber the system. So I can't go through the 7 modes that way without renumbering the same shape. That's inefficient. What would be the most efficient way? To learn the modal points. I want to learn the modal points and memorize those because those are good for the modes and they're good for shifting. That's what you are in essence doing when you're memorizing by shape. You're memorizing all the nodal points. All you want to do then is name those nodal points. And that'll give you the modes. And then you want to look at the distances between the modal points. That'll give you the distances, or which we call the scale degrees. And so that's the general idea that we'll get into. All right. So let's think about the notes then normally. How is the normal convention of the notes? We've got an A. You got A through G, right? What normally happened, or how did they do this? If you think of the piano, you can think of the scale of 7 notes. They put the 7 notes on. You can just imagine the black keys aren't there, and they just said 7 notes. Now, I just want to imagine. I'm not saying this is exactly what happened, but I want to try to imagine what happened like you would do if you're looking at a system that doesn't look quite right, and you're trying to say, what were they thinking? Like if I'm an accountant, and I see a chart of accounts that's all messed up, then I want to go back and try to get in their mind and say, how did this progress? How did this possibly happen? And I'm thinking that they were probably saying, hey, look, I'm trying to teach people who possibly aren't going to advance that much in music, that maybe they're singing and things like that. And I just want to have one key where everything sounds good in one key. So and I'm just going to pick a key with the key of C, and I'm going to make an instrument where I can play everything with a nice keyboard. And I'm going to ignore everything except the key of C and the related modes. And all the related modes are similar. They're all parallel constructions. So that would make sense if that's what you wanted to do, right? So then you got A through G, even though C is kind of like the main key that we think about as the major. But then you wanted to add the other notes. But you couldn't add the other notes. That's like creating a numbering system for your general ledger accounts of 1 through 7, and then realizing that you need 12 notes. I have to stick in the other notes, but I can't because I don't have a position between them. I would have to use like a 0.5, but you can't use a 0.5 if you use letters because there is no 0.5. So I have to put something in between it. So that's what happened here between A and B. These are the notes that are in the key of C. I had to stick something in between it. So what am I going to stick in between it? I can't call it an A.5, so I'm going to call it an A sharp. So I can call it basically an A sharp. Now notice if I call it an A sharp, what's going to be the argument? Well, why is it an A sharp? It's halfway between an A and a B. It's as close to the B as it is to the A. So why would I have 2 A's then? I should sometimes call it a B flat, right? So now we have this system of, well, it's sometimes going to be an A sharp and sometimes a B flat because it should be like a 1.5. But now we have to say an A sharp or a B flat. Now, when might we use an A sharp or a B flat? Well, you don't want two A's next to each other because that would be looking messy if you're trying to write things by hand and people have bad handwriting and stuff. So oftentimes when you're spelling things out, you can choose either of these notes, right? And what you're usually trying to do is avoid having two of the same note, right? You're usually saying, I don't want two A's next to each other, therefore I'm going to make this one, which would be an A sharp, a B flat. That's what ends up happening. Or as a general rule, when we're counting up in pitch, down in terms of the way I've listed it here, then we go, then usually we're going to go to a sharp, A sharp, B, and so on. And when we're going backwards, as a general rule, we want to go B, B flat, A. Now, so that's going to be, you can see logically kind of how that happened, but let me just list out, obviously that causes all kind of problems, right? Now, the other thing that's kind of cool about that, however, is that we start to see patterns in the system. So if I start looking at the circle of fifths, for example, and I start building out scales, I start to realize, hey, look, I can build all of my 7-note scales out of the 12 notes with every letter in the alphabet, A through G. And isn't that cool? And it's like, well, that's cool. Well, but the only way I was able to do that is to say that I don't want two notes next to each other. So I had to nudge all of the notes to be either a sharp or a flat. So do you see, you come up with cool things, that patterns that you're seeing in the system, even though the system is overly complex, in part because it's laying on top of something that's symmetrical, right? You're looking at just a numbering system of 1 through 12, and then we put this kind of weird pattern on top of it, which is going to generate interesting, weird patterns once we start to analyze it, such as all the notes having this one letter, and then we can kind of see the pattern for the sharps and the flats, how many sharps and flats are going to be in each scale. If we look at C major, D major, and so on and so forth, interesting patterns. However, it's really unrefutable. I mean, put it into a ChatGPT or some kind of logic-based system and ask the question from just simply a system-based system, are the benefits of this sharp flat system outweighing the cons? And I think, and tell me why. And I think, and again, it's not just me. It'll list it out. Give me the history of it. Just give me the history. It'll list it out. It's beautiful. And you'll be able to, and so it's not just me saying it. I mean, I think it's just clearly a fact that it's not the most efficient system, right? So the things that we want to be aware of then is that when we look at a piano, it's so cool that you can play just the white keys. I used to do this as a kid when people left the house so they don't make fun of me, right? It's because I don't really know what I'm doing. But I can like tap on the piano and I could make different rhythms as long as you're in the key of C. That's great because then you can focus on rhythm and stuff like that. But you have to kind of unlearn that to some degree to then realize what's really happening is you've got 12 notes that are all the same, and they've already picked 7 notes using the formula. Okay, so let's keep going. We're going to go from B. So then we have what we call a natural half step between B and C. Again, this is not really natural. It's only natural because the key of C was made first, right? If we had 12 notes and we just applied the formula to any of the notes, the half step might lie anywhere. So again, this is another kind of problem that is a result that shouldn't be. It's leading us to a presumptions that is not exactly right, which we can rectify with a numbering system where we can clearly see that all these notes are simply evenly spaced, numbered 1 through 12, right? And then we have a C sharp, and then we have a D, and then we've got the D sharp. Now notice that C could also be called a D. If we're going the other way, it would be a D flat. And then we've got the D, and then we've got either a D sharp or an E flat. Also note that these little hashtags, This looks like it's a hashtag, but it's actually a number sign for music.